You are welcome to today's class. And today's class we are going to continue from where we stopped with our chemistry. So today we are going to be talking about elements, compounds, and mixture in chemistry. So in chemistry, what do we mean when we say something is an element, or when we say it's a compound, or when we say it's a mixture? What's actually the meaning of these three terms? Now, so in chemistry, when you say something is okay, doesn't matter. So in chemistry, matter can either be a pure substance or an impure substance. So that means that we stopped on matter, and we said that all substances are made up of matter. Now they are not trying to tell us something more about matter. That any form of matter you have, it is either it is pure or it is impure. Now, so if it is now pure, it can be divided into two. It's either is an element or it is a compound. That is for a pure substance. A pure substance is either an element or it is a compound. Now, but if it is impure, then automatically it has become a mixture. So this is like the basis for the three of them. That whenever you are talking about elements and compounds, you should have it at the back of your mind that you are talking about pure substances. But unless otherwise stated, unless they tell you otherwise that these substances are not pure, that's when you can assume that they are not pure. But if someone just mentioned to you that we have an element or we have a compound, automatically you should know that they are pure. But when you are talking of impure substances are generally mixtures. So mixtures are impure substances. So that's the first thing I want us to know about them. Now another thing we must know is that both pure and impure substances can be separated into components. That means that it's either you are having a pure substance, which can be an element or a compound, or you are having impure substance, which can be a mixture. They said they can still be separated into components. But what? But a pure substance can only be separated using chemical methods. So that's like a basic difference between a pure substance and an impure substance. You can separate a pure substance only with chemical methods. That means that you require a chemical change before you can separate a pure substance. But impure substances can be separated by physical methods. That means that for an impure substance, you just need a physical method to separate it. And what do we mean by physical method? It means a method that is not going to change the form of that particular substance. That's what we mean by a physical method. A method that is not going to change the form of that particular substance. So this is like a kind of basic knowledge that we are supposed to have. That whenever you want to separate a pure substance, you need what? Whenever they say something is pure, that means that you need chemical method to separate it into its components. Now, and whenever they say something is impure, whenever they say, whenever they say something is impure, it can be separated by physical methods. But you should know that the impure that we are talking about here, we are actually talking about mixtures, because of the next statement that is going to come. Now, look at this. Also, an element or a compound may become impure when it mixes with other substances, which means that you can also have it that an element which is supposed to be pure can also become impure. That means it is no longer pure when it has mixed with other substances. The same thing with a compound. A compound may also become impure when it mixes with other substances. But the basis of everything is that whenever you have an element or a compound, both of them are going to be pure unless they are allowed to mix with other
substances, that is when they are going to become impure. Now I hope this is very understandable. Element is a pure substance. A compound is also a pure substance. The only case when they will not be pure substances are when they have mixed with other substances. So we are going to see examples that will make us understand this better. Now, so going into the details, we have an element. Now, an element is just a substance which cannot be broken down into smaller units by ordinary chemical process. That means that whenever you have an element, you can never break down an element. It is not possible. So once you have an element, you already have the smallest that you can have. That means that breaking it down further does not make any sense, does not lead to any unique identity. It does not give it another identity. Now look at this. They said example is oxygen. Now in chemistry, we represent oxygen with O. Hydrogen, we represent it with H. And gold, we represent gold with AU. Now this oxygen, is not possible for you to break down oxygen. If you break down oxygen, the new thing that you are going to have is not going to have name. It's not going to be represented as an element in, there's something we call the periodic table. That's a table that contains all the elements that we have in chemistry. So whenever, if you break down oxygen, what you are going to have inside oxygen is also something that is making up hydrogen, and it is also something that is making up gold. It is something that makes up all the other elements that we have in the periodic table. But once you break them down, you can't have a unique identity anymore. Now, what I can actually use as an example of this is, let me use sand. Let me use sand and water. Now, it is possible for you to mix, okay, let me add cement. Now, it is possible for you to mix sand and water and cement, and it's going to form a block. And it is possible for you to mix the same sand and water and cement, and for you to make it to form a brick. Now, the difference between blocks and bricks is that bricks are usually, they usually look like cubes with no holes in them. Now, blocks, they also resemble, a brick resembles, what do I call this? A cuboid. You can't call it a brick, it resembles a cuboid. Now, but for a block looks like this, then it has holes. It has two big holes. Now, when you see this, what will you call it? You will say it is a block, right? When you see this, what will you call it? You also say, this is a brick. So, which means that a block is not the same thing as a brick. But you know that inside a block, what do you use to make block? We use sand, we use water, we use cement. What do we use to make a brick? We also use sand, we use water, we use cement. So meaning that both block and brick are both composed of the same thing, but the manner in which they are mixed is different. For example, if you want to make a block, you require more of sand and water. Although cement is also mandatory, but it is possible that you use little amount of cement. But whenever you want to make a brick, you also require sand, water and cement, but you require more of cement because bricks are always stronger than blocks. So that is trying to tell us that although they are composed of the same thing, but those things that make them up are in different quantities. And that leads us to saying to the same thing that is happening with oxygen, hydrogen and gold. Now what we are saying is that if you break down oxygen, inside oxygen you have particles inside. We have what you call the proton, we have what you call the neutron, and we have what you call the electron. Also the same thing with hydrogen. Inside hydrogen we have the proton, we have the neutron, we have the electron. And inside gold we have the proton, we have the neutron, and we have the electron. But the amount of proton that oxygen has is different from the amount of proton that hydrogen has. which is also different from the amount of proton that gold is having. So that is trying to tell us that what? That although they are composed of the same particles, they contain different amounts of these particles. Just like we have our block that contain less of cement, and we have our brick that contains more of cement. So that is what they are trying to tell us with elements, that if you still break it down into smaller units, you can do that, but it is not going to be by an ordinary chemical process. So that means that it's not possible for you to break down oxygen into smaller units unless it's not an ordinary chemical process. And when you break it down, what you are going to be having are just the components of oxygen, which is the same thing as the components of all other atoms, all other elements that we are also having. Now, so the same thing for hydrogen and the same thing for gold. So there are actually lots of elements that we have in chemistry. So what is a compound? So a compound is what we form when we have when elements combine chemically. So this is when we have a compound, when elements combine chemically. So if your elements combine but did not combine chemically, you can never call that a compound. So there must be a chemical reaction before you can have a compound. Now note, that is not the same thing for elements. Some elements actually exist naturally. That means that's how they just are. And there are some elements that they are produced artificially in the laboratory. So there are some elements that exist naturally, and there are some elements that we produce them artificially in our labs. So that's it for elements. But for compounds, you can always form a compound by what? By combining elements chemically together. That is how we form compounds. Now, so examples of compounds are water, carbon dioxide, quicklime. Those are the examples of compounds. So there are lots of them, but we need to know them. Now, a very easy way for us to identify a compound is that a compound always has a fixed way of combining elements. Although this is not the case, I actually said that out of context. We'll later talk about it. Now, so they said a given compound always have a fixed way of combining elements, and it maintains a particular percentage. What we mean by this is that, for example, water, the chemical formula for water is H2O. That means that anywhere you see water, it must contain 2 hydrogen and 1 oxygen atoms. So if you want to say it normally, what you just say is that hydrogen is an element, oxygen is also an element, and both of them combine chemically together to form water. That's what you are going to say. So water is a compound that is composed of what? 2 elements that react chemically together. Now, anywhere you see water, this is always what you always see: 2 hydrogen and 1 oxygen. So that's what we mean by it has a fixed way. It will always be like that if it is water. Now, if it is another example of element compound, carbon dioxide. Carbon dioxide is always CO2. That's how it always is. So that means it contains 1 carbon and 2 hydrogen atoms. Or if you want to say it, you say it contains carbon as an element, it also contains oxygen as an element, and both of them are chemically combined together. So this is what? This is also a compound. Anywhere you see carbon dioxide, it will always be like this. So it is fixed. Another example of a compound that we can use, our table salt. The salt we put in our foods is sodium chloride. This is also an example of a compound. Look at it, contains 2 elements. Sodium as an element, chlorine as an element. Now, if you look at anywhere you see sodium chloride, which is table salt, it will always be 1 sodium atom and 1 chlorine atom. So that's what we mean by they have what? A particular percentage, and they have what? They are fixed. Now, so another thing we must know is about mixtures. Now, mixtures contain, look at this, a mixture contains 2 or more substances, and those substances, they can be elements, they can be compound, they can even be other mixtures. That's why a mixture is very complex. But they can what? They can be separated by physical means. So which means that anything that you can separate by a physical means that that particular thing is not combined chemically. That's why you can separate it by physical means. Even for elements, you can't separate elements by physical means. That's the first thing. You can't also separate elements by ordinary chemical means. Look at this. You can't separate them by ordinary chemical process. It's not possible. So you have to find some kind of nuclear reaction that is going to happen before you can before you can break down elements into their components. But that's not important for now. Just know that elements cannot be broken down by ordinary chemical process. Now, because they have a unique identity and they will always contain only one symbol, just like we did the other time, that oxygen is O, hydrogen is H, gold is Au. But look at it when I wrote the chemical formula for water. Now, when you see only one or two alphabets like this, we call them symbols. We call them chemical symbols. But when you want to write for compounds, what you write for compound is what? Chemical formula. That's why for water we wrote H2O. As you can see, it contains two different elements. Look at oxygen standing alone, that's an element. Hydrogen standing alone, that's an element. But when both of them come together, they become compound. This is to show you that this is what? It is a compound because it contains two or more elements that are chemically combined. Now, but for a mixture, you can't say that for a mixture, because, for example, our water is actually a compound and it is a pure substance, because we know that compounds basically are pure substances. But it's possible for this water, for salt to pour inside this water. Now, if salt should pour in water, we are going to call it what? A mixture. Why is it a mixture? Because that salt did not react chemically with the water. We all know that this happens and we have mentioned this example before when we were discussing physical and chemical changes. We said that when you pour salt in water, when you pour it in water, what are you going to have? You are going to have salt water, because the salt is still inside the water. So it is what? It is a physical change. So that means that there is no chemical reaction. So salt in water is an example of a mixture because they did not react chemically together. But I didn't mean that they react chemically together, just like oxygen and hydrogen. They are going to form what? A compound. But salt is a compound on its own, which is a pure substance. Water is a compound on its own, which is also a pure substance. But when salt is poured in water, what you now have is salt water, which is not a pure substance. Now, why did you say it is not a pure substance? Because you can separate it. We can have salt separately and water separately. By the time we just put it on fire and try to evaporate the water, you are going to be left with just the salt. So that is like a proof to tell us that what? That salt is a compound. Because if you just, there's no way you can separate salt. Although you can separate salt, since we say salt is sodium chloride, you can split it into sodium element and chlorine element. But that does not stop it from being a pure substance. It is still a pure substance because it has a unique identity. And it is a pure substance because it is a compound. Because they have told us from the beginning, where is it? They told us from the beginning that pure substances are either elements or compounds. So whenever you see an element, you are sure that it is a pure substance. Whenever you see a compound, you are also sure that it is a pure substance. So it is only mixtures that are not pure substances. So look at this. So this is what I just said. Elements have a chemical symbol, compounds have a chemical formula. So what we mean by formula means that there are a lot of symbols inside it. Then this shows that elements, they show the elements in that particular compound, just like water. So this is to show us that inside water we are having hydrogen and oxygen. Also the same thing with sodium chloride. This is to show us that inside salt we have sodium and we have chlorine. So lots of them like that. But air is not an example of a compound, because inside air there is no, if it is going to be a compound, there's going to be a formula that we can write for it. There's going to be a formula that we can write for air, but there's no formula for air. There's no chemical formula for air. We just know that air contains a lot of gases. It contains oxygen, it contains nitrogen, it contains rare gases. Those are the components of air. It also contains all other stuffs, but all of these, they are just there, they are not chemically combined together. That's why we call air also a mixture. Look at it here. Air is also an example of a mixture because the components are not combined chemically.